OK, Miss Armit, what exactly is the particle model?
So the particle model is a way of explaining the way particles move and collide. There's 4 things you need to know about it. All substances are made of particles. The particles are attracted to each other, some more than others, and the particles are constantly moving with what's called kinetic energy. As temperature increases, this kinetic energy increases so they can move around more.
OK, those are the 4 things to remember. Now, substances are made up of solids, liquids and gases. Do the particles move around in the same way in each?
No, not quite. They move around differently in each one. So in gases, they're far freer to move around than in liquids and the solids. They have a lower density and they're far apart. In solids, they're much closer together and they can only vibrate. And liquids are kind of in between. Their particles are spread out randomly and their density is less than their solids but higher than gases.
The particles that make up gases and liquids move randomly. This movement allows the action of diffusion to happen. For example, if you spray some deodorant in your bedroom, the particles move from an area of high concentration, the place where you sprayed it, to an area of lower concentration, your bedroom doorway, then through the rest of the house. The perfume particles have diffused.
I got all excited because I thought Miss Armit had brought in sweets and balloons for a bit of a party, but that's not the case. It's actually for an experiment. But how and why have you brought them in, and what's it got to do with the particle model?
Well, particles are too small to see. So in order to demonstrate the particle model, we use these to help demonstrate it, so we can see them in different states of matter.
What about diffusion? Can it happen in all states? And by that, I mean solids, liquids and gases.
So it happens mainly in liquids and gases. And this is because the particles can freely move around. It doesn't really happen in solids, as the particles are in this fixed position and they can only vibrate on the spot.
All right. And have you got an example of that in front of you then?
Yeah, just here. I poured some water on this plate earlier, and this is before and after. So what happened is the food colouring on the outside of the sweets has dissolved into the water, and then it's moved from the high concentration of the food colouring around the sweet to the lower concentration in the middle. And you can clearly see the diffusion is illustrated.